Let's look at the solution of this test. The first question, we are asked to comment whether fx equal to sine ax is even, odd, or neither. Now, let's look at what kind of a function sine ax is. A lot of you might be knowing that sine x is a graph of this form, where it starts at 0, at pi again it crosses 0, and at 2 pi again it crosses 0, and it reaches a maximum of 1 and a minimum of -1. What happens if we replace x by ax? What it changes is the frequency of the graph. So the maximum still remains at 1 and -1. Ax will only change the frequency depending on whether a is greater than 1 or less than 1. Can predict whether the graph would squeeze or would expand further, as in whether its frequency will increase or decrease. But what is to be kept in mind is the amplitude remains the same. If in place of sine ax we had the graph a sine x, points at which it turns 0 would have remained the same, but the amplitude would have changed to a and -a. And you should think why it happens. By substituting different values of x, you would be able to figure out why the graph change as they change. But this information is directly not required in this question, but I thought it was a good time to expose you to these graphs. The way to solve this would be, one, you can solve it graphically. If you look at the graph of sine ax, and you would notice that it's symmetrical about the center. It's not symmetrical about the y-axis, but it's symmetrical about the center, which means it's an odd function. The other way would be just substituting -x in place of x, and you would need to know this identity that sine -x is equal to minus sine x, and in fact cos -x is equal to cos x. So using this, if you substitute minus in front of ax, you will get minus sine x, and that will also indicate that this function is an odd function. In this question, we have to predict whether e to the power ax is even, odd, or neither. Again, you can substitute x as minus ax, and you would know that it is not an even or an odd function. When you substitute minus ax, it doesn't change to fx, it also doesn't change to minus fx, and hence it's neither odd nor even. We will look at the graph as well in the exponential section, but if you want to know right now, e to the power x is of this sort, and if a is greater than 0, then this graph becomes steeper, and if a is less than 0, then this graph becomes more flatter. In this function, we have to predict whether x to the power m is even or odd, and it's very straightforward. You just substitute minus x in place of x and check, and it's a relationship which you should remember and know on your fingertips, that if m is even, then the function would be even. If m is odd, the function would be odd. So x squared, x to the power 4, x to the power 6, all these functions will be even. X cubed, x to the power 5, all these functions will be odd. And even for the negative numbers, so x to the power -2, x to the power -4, these functions will be even, and x to the power -1, x to the power -3 will be odd. The graph of x squared, x to the power 4, x to the power 6, x to the power m with m positive even will be a U-shaped curve, which keeps getting steeper as you keep increasing the value of m. On the other hand, the graph of x cubed, x to the power 5 will be of this sort, which again keeps getting steeper as you keep increasing the value of m. 1 by x squared, 1 by x to the power 4 will have a graph of this sort, while 1 by x and 1 by x cubed and so on will have a graph of this sort. We'll study all this in more detail. I'm just exposing these concepts to you right now, but we will get to them when we study graphs. In this question, fx is an even function and gx is an odd function. We ask which of the following is true. So we have to comment on fgx and gfx. When you put x as minus x in fgx, what happens is, since gx is an odd function, with g minus x is equal to minus gx, but since fx is an even function, f minus gx is same as fgx. So since fg minus x is same as fgx, it's an even function. Gf minus x, when you substitute minus x, since f is an even function, f minus x will be equal to fx, so gf minus x is equal to gx, and then this is also an even function, so both functions will be even. On the other hand, when you have to add f minus x plus g minus x, and both of these functions are odd in this question, so we have changed a bit. When they are odd, f minus x plus g minus x is equal to minus fx and minus gx. When you take minus common, it is a negative of the first function we started with, and hence it is an odd function. When you multiply two odd functions, f minus x into g minus x, you get minus fx into minus gx, which is equal to fx into gx, because minus minus will cancel, and hence it's an even function, as f minus x g minus x is equal to fx gx. We can also do these kind of questions just by putting an example in here, especially if neither is not an option. So the way we could have done it is we could have taken as x and gx as x cube, and we know both of these are odd functions. So f plus g would have been x plus x cube, and fg would have been x to the power 4. We know this is an even function, so we know fg is even, and you can substitute x as minus x here and check that this will be an odd function, and hence we know that f plus g is odd and fg is even. You can do the same thing with the previous question as well. Thank you.